Alright, so here is the key from the Chapter 2, Sections 1 through 5 quiz. You can see the answers here. This one is no solution. I had originally put a circle with a line through it because sometimes that's shorthand way to write no solution, but it is no solution for that one. So now I just kind of want to show you the work involved with getting these solutions. So first of all, number 1, here I started by combining like terms to 9z, and then I used inverse operations to get z by itself. Subtracted 6 and divided both sides by 9 to get z is 2. So there's my solution. Z is 2. In number 2, I started with first distributing, multiplying 7 by h and 3 to get 7h plus 21. Brought down the 4 and the negative 3 on the other side. I had to combine like terms. Here, 21 and 4 can be combined to positive 25. And then from here, I use inverse operations to isolate the variable to get it by itself. First by subtracting 25 from both sides, and then dividing by 7, getting h is negative 4. Here's number 3. So the way I went about number 3 is rather than distributing the fraction to inside the parentheses, we talked about how you can get rid of a fraction outside of a set of parentheses by multiplying by the reciprocal. So that's what I did in this problem. So these cancel out with those, leaving you with 4x minus 7. By multiplying by 3 halves here, you get negative 3. And then from here, you just simply use inverse operations to isolate the variable, and you do get that x is 1. For number 4, I showed you 2 different ways that you can go about doing it. So in this side here, I decided to distribute the 3/4, giving me 3/4 y plus 3 halves. And then I subtracted 3 halves from both sides, and which gives me this here, negative 15 halves, or you could write it as negative 7.5 equals 3/4 y. And then from there, to get rid of the 3/4 in front of y, I multiplied both sides by the reciprocal by 4/3, and that gives me y as negative 10. In this problem, what you could have done is you could have right off the bat turned 3/4 into 0.75 if you prefer working with decimals. But you'd be able to do that in this case because it's a terminating decimal. If it's a case where the decimal is repeating, you don't want to estimate that and round it because then your answer is not going to be accurate. So another way to do this problem is, rather than distributing through, kind of similar to the last one, I multiplied both sides by the reciprocal of the fraction that's in front of the set of parentheses. Rather than distributing this, I multiplied by 4/3 on both sides. So here, that gives me negative 8 equals y plus 2, and then I took away 2, and I get the same answer. You can just see so this side requires a little bit less work. Then on to number 5. So here's one where the variable is on both sides. So I take care of that. I chose to get rid of the smaller of the two. This is a negative 11x, so I added it to both sides, which results in this equation here. Then I just need to get x by itself. So I add 12 to both sides, divide by 18, and I get that x is equal to 1. And so that's my final solution. Number 6, I started first by distributing, multiplying 3 by 4y and 3 by negative 5, resulting in this equation here. Then I need to get the variable on one side. So there are no like terms to combine. I just need to worry about getting all of my y's on one side of the equation. So I chose to take away 2y here, which eliminates my y's, but I also got to do it over here, which results in this. And then I just concentrate on getting y by itself. So I add 15 to both sides, divide by 10, and I get that y is 2. In number 7, this one's a little different, similar process though. First I distribute here 12 times x and then 12 times 3. There are no like terms to combine on either side, so I work on getting the variable by itself on one side. So when I go to subtract 12x here, what happens is it also gets eliminated on this side because they have the same coefficient of 12. Well, what that leaves me with is 36 equals 24, which is a false statement. Okay, so in the process of solving, my variable was eliminated, and I'm left with a false statement, which leads me to conclude there is no solution to this equation. In number 8, this required me to distribute on both sides of my equation, multiply 5 by everything in there, multiply -4 by everything in here. Then I need to concentrate on getting the variable on one side of the equation. So I chose to eliminate the -4x on the right by adding it to both sides. Results in this equation here, 4x minus 5 equals -12. And then I just use inverse operations from there to solve and get x by itself, which is either -1/2 or -0.5, however you choose to write it. Here's number 9. So again, distributing is required on both sides of the equation here, which results in -6 plus 2m equals -3 plus 3m. I have variables on both sides, so I need to eliminate them from one of my sides. I pick the smaller of the two. This is positive 2m, so I do the opposite. I subtract 2m. Leaves me with this equation here, and then I just simply add 3 to get m is -3. Now in this last problem, you were initially given that a triangle, now you don't know what kind of triangle this is, but the sides can be represented with x, 3x minus 1, and 4x plus 2. And then you were also told that the perimeter of this triangle is 81 inches. Well, remember, you always find perimeter by adding up all the sides. So if I add up all these sides, so 4x plus 2, 3x minus 1, and x, they should equal out to 81. So if I construct that equation, I can then solve it for x. Okay, I combined like terms, 4x plus 3x plus x is 8x, 2 and minus 1 plus -1 is 1. And then I can solve this equation for x. Take away 1, divide by 8, I get x is 10. However, I'm not done because the question was, what would the length of each side be? Well, if x is 10, remember side 1 is x. So whatever x is, that's side 1. So x is 10, side 1 is 10 inches. Be sure to include your unit. Side 2 is 3 times x minus 1. So we replace x with 10. 3 times 10 minus 1 is 29. And then finally for side 3, we replace the x with a 10 once again, and we get that it is 42. So the dimensions of, or the side lengths of this triangle are the following: 10 inches, 29 inches, and 42. I know several of you took 81 and divided by 3 to get that each side was 27. But you cannot assume that each side is the same, and in fact they're not, because one side is just simply x, another side is 3 times that amount minus 1, and then another side is 4 times that amount plus 2. So they're definitely not the same amount. They are different, and that's how you go about finding that.